Hi guys, in this video we're doing electrostatics again. So in this video again, I assume that you already know Coulomb's law. I mean, like, you know the law, not how to solve all the problems. You know how to state the law. So if you know how to state the law, therefore you know this formula, that F is equals to K Q1 Q2 divided by R squared. And you also know that if you have two charges that are oppositely charged, they're going to attract each other. If you have two charges that are equal, are the same, like they got the same, like both positively charged or both negatively charged, they're going to repel. So these are the two things that I'm assuming that you already know. So after that, in this video we're going to solve like few examples, trick examples. So let's look at this one here. This is going to be our example 2, since in the last video we solved the other one. So this is going to be example 2. So it says 6 ions are locked in a square pyramidal structure as shown in the figure 1. So this there is the figure 1. So this is the pyramid. You know how pyramid looks like. So you got the 1 2 3 4 5 6. Okay, so that's true. So that's true. We have 6 ions. So the length of each side of pyramid is equals to A, and A is equals to 0.13 nanometer. Okay, so we're given that this length here is equals to A, and A is equals to 0.13 nanometer. And the sixth shown in green ion is at the center of the base. So we can see this one here that's shown in green. This one here, this is shown in green. So it's at the center of the pyramid, at the base of the pyramid. Calculate the vector sum of the electric forces exerted on the top ion if each of the 6 ions is missing 1 electron. So okay, so the trick is here, if okay, let me use a different color. So it says if each of the 6 ions is missing 1 electron. So therefore, if one ion, if we have an ion, so let's say this is an ion, this ion, it's let's say it has 6 electrons and 6 protons. So therefore we say that this ion is it's a neutral. It's not negatively charged, it's not positively charged. But if we have this ion that's missing one electron, therefore it's positively charged, because if 1 electron is missing, it's gonna left with positive, and then if it's positive, it's gonna be a positively charged ion. So it's got 1 extra proton. So this, you know that the charge of an electron is equal to the charge of of proton, which is 1.602 times 10 to the power minus 19 coulomb, right? So that's the charge of a proton or charge of electron. So therefore that's why it's plus or minus. It's plus or minus. If it's plus, therefore that means it's a proton. If it's minus, it's an electron. Okay, so let's get started. Okay, so here our question says that we have to calculate the vector sum of electric forces that are exerted on the top one. So to do that is too easy. What you have to do here, you can see that this is like a complicated diagram. We have many ions. So what you have to do is just to try to come up with a better way to simplify this problem. So okay, so the better way to simplify this is to draw the free body diagram. So we're going to draw a free body diagram here. Free body diagram is going to solve all of these things, gonna make everything simple. So let's take the top ion. This is a top ion. This dot represents the top ion, right? So you know that if this is, it's positive and this is positive here, they're going to repel. So one force is going to be exerted in that way, right? So we're going to have a force that's going this way with an angle. We don't know that how much is that angle. Let's call it theta. So even this one here, if this is positive, this is positive, these two, they're going to repel. So if they repel, there's a one force is going this way. So we're going to have another force that's going this way. So let's call this F1 here and call this one F2 here, right? So it's also exerted at an angle. We don't know how much is that angle, right? So now we're left with the green one. So the green one is gonna since it's also positively charged, it's gonna exert a force that's going upwards. So this force is directly upwards, right, which is at an angle of 90 degrees. So okay, we see now we did this for this one, and the green one. So this is gonna be the reflection of the other two ones there, because these two are also positively charged. They're going to do the very same thing. So from this sketch now we can tell something. What's that? Is that we see a symmetry. So what's the symmetry here? Is that F1 and F2, they're equal because they have the same amount of charge. They're exerting the force at the same distance A. Both of them, they're exerting a force at distance A. So therefore we can simplify the problem by saying that F1 and F2 they're equal, which are right. F1 and F2 they're equal, right? So therefore if these forces are equal, and remember that they're like this, so if forces are like this, they've got a vertical and horizontal component. So what you can tell about the horizontal component is that the horizontal components of these two forces are equal because they point in opposite direction. They're going to cancel each other. So the only forces that we are going to have is the vertical component. Okay, I hope you get it. You can see that if this force here F1 is equals to F2, and these two forces can be decomposed like in a vertical and horizontal component. A vertical component of these two forces, both of them are going upwards, so therefore they add up. A horizontal components that are going in opposite direction, therefore they cancel each other. So we are going to have the sum of f of x of in this problem is going to be 0. This charge, the top charge, will never go to any direction in the x direction, because also the one that is at the center, the green one, you can see that the green force here, it's going upwards, which means the only forces that you have are going upwards. So which means that's the Fy, the sum of the forces. So they said our question said calculate the vector sum of the electric forces exerted on the top ion if each of the 6 ions is missing 1 electron. So okay, so now we already know that, okay, since the f of x is equals to 0, what we are concerned now, the vector sum is going to be the vector, the y component of all forces that are going up. Okay, so I hope you got that. Okay, so now we know that this sum, the Fy, the sum of Fy, that's what we are looking for, is going to be the F1y, the f of 1y, the one that's the vertical component of F1, plus F2y, plus F3y, plus F4y, and we know that F5 is the green one, is the green F5 by itself, it doesn't have any horizontal component, right? We can see that this is directly to charge, so meaning that doesn't exert any horizontal component force. So we can just write that there's a F5. We don't have to specify that it's a F5y, just F5, right? So all of these forces, and we know that from Coulomb's law here, what is the F? F is equals to K Q1 Q2 divided by R squared. Okay, so now we have an idea of how to solve this problem. So now we're going to just to copy this and solve it in the next page. Okay, so now we want to solve the sum of Fy. So that's what we want to solve. And again, we can see that from this sketch, the sum of Fy of these 4 charges, all of them, it's exerted in an angle. So now we have to find that angle, because the Fy, as you can see, is this one here. So this is the Fy, while this is at an angle of this. So now we have to check that angle. So to do that, let's just draw a sketch. So this is going to be the red one, and then this is going to be the red one. So after that, we have a green one here, we have a green one here. So after having a green one, so we're going to do this, and do this and do that, right? So we can see from this sketch here, this sketch is this one here. If you can trace it here, is this sketch. That's what I did draw. Remember that this is 90 degrees here. It's 90 degrees. So from that sketch, let's call this a height. That's gonna be a height. All right, so that's a height. It's this h here. So from this sketch, you can see that this one here is a half of this. Okay, so if it's the half of this, let's draw that again. So this is gonna be like this one here. If you draw that, it's gonna be like red, and then another red there, and then another red there, while the green is here. So while it's doing this, we know that this here is 90 degrees. So if this here is 90 degrees, while this, we know that this is A, we can calculate this one here. Okay, so actually I don't think you do understand this. Let's draw it in a proper manner. Let's just draw a square base. So let's say we have a square base is like this. We have a square base, and then at the corners we know that we have all red, and then at the center we know that we have a green. So this is the line, this is the line. So we know that this is A, this is A. So now this part here from our sketch, from this sketch here, we know that this portion here is the same as this one here, the half of this hypotenuse here. You can see that, right? So now what you have to do, we have to find the distance from here to there, which is it's a hypotenuse, and then divide it by 2. When you divide by 2, this distance here, let's call this distance x, is the same as this distance here. Both of them are x, because a half of the hypotenuse of a square base. Okay, so to find that, we know that here we can use a theorem of Pythagoras by saying the whole of this is r, then r squared, we know that's gonna be equals to a squared plus a squared. So which this is going to be give us a square root of 2. So if we need the half of this, we divide it by 2. So therefore the x is going to be a square root of 2 over 2, right? So that's x. So after getting now we're fine, or cool. Now we got our x. So after getting our x, we can find h. What's h? So by doing that, we can use the theorem of Pythagoras again, because we know that this is a, right? We know that that's a, this is a. So therefore now we have this h squared is equals to a squared minus x squared, right? So h squared is equals to what's a squared? A squared is just a squared minus x squared, we got it here, which is going to be a squared is this one here, multiplied by 2 over 4, right? So which this is h squared is going to be equals to, you know that this is going to be half minus 1 is half. So therefore we're going to get half a squared, right? So therefore what's h? H is equals to a divided by square root of 2. Okay, so now we're cool with that. So if we got that, what you have to do now, we have to substitute in our equations here, because we're looking for h here. That's what that was the only thing that we're looking for. Oh, I forgot, not h only, also this theta here, because as we said that this is going to be our vertical component. All of these forces, they are going to act in this direction, so which is what we call a vertical component, Fy. So now we have to calculate, because this is F, so Fy, you know that Fy is equals to what is this, since this is in this direction, so it's gonna be F sine of theta. So now we have to get what theta. So to get what it's theta, you have to do that by using a sketch. So you know from our sketch, we got this. We got that this is h, this is f, this is a, and this is x, and we know what x is. X, we got h, we have it. So now we can just use the simplest one. All right, so we can just use a and h, saying that sin theta Sin theta, right, is equals to, this is theta, right? So sin theta is equals to opposite, which is h over hypotenuse, which is a. So therefore, if that's the case, what's h? H is a over the square root of 2. Then we can multiply that by a. So a, what's a? A just a, right? So which this is going to be 1 over a. Okay, so a can cancel a, therefore we're left with 1 over square root of 2. That's it, it's a sin theta. So sin theta is equals to that. Sin theta is equals to that. Okay, so if you got that, now we just have to go and substitute. Now we have everything that was needed. So now we just have to go back and substitute. Let's copy and paste and do this to next page. Okay, so let's complete this. Okay, so to complete this, we know that since all of these forces are going to be equal, all of these forces here that are in red are going to be equal, because from our sketch here, the previous sketch, we said that this is going to be exerted force that is equal to the force exerted by this, which is equal to the force exerted by that is equal to the force exerted by this. So all of these are going to exert an equal force. So therefore, to simplify the problem, it's just to write this as one force. So therefore, we can just say sum of Fy is equals to, since because this is equals to that and that, it's just F for Fy, right, plus F5. So now we know what's F. From Coulomb's law, we know that F is equals to K, Q1, Q2, divided by a distance between them, which is r squared. Okay, so we're going to say for the distance between the top and the red ones, remember that's a, right? So it's going to be a. So since, because we're looking for the Fy, and we said that Fy is going to be the actual F multiplied by the sine of theta, right? So now we're going to substitute what's Fy. So Fy is going to be F, right? Which F is the same as K. Q1 and Q2, since if these two are the same, are going to be just Q squared divided by R squared. R squared is the distance between them, which is A squared, right? In this case. Then we say sine of theta. So sine of theta, let me not waste time to write sine of theta. We know that sine of theta is equals to this, right? So if it's equals to that, therefore we're going to say multiply by 1 over square root of 2 plus the F5. This F5 is, it doesn't have a y component. By itself it's already the y component, is this one here. So that's just going to be the F of K, Q1, Q2 divided by H squared. So we know what's H. We know what's H also. We know what's H. So we're going to say this is K, a Q squared divided by what's H. H, we got it here, which is a squared. It's going to be a squared over 2, right? So this is what we got. And then let's write this in a proper manner. This is going to be 4kq squared divided by the square root of 2a squared, right? And then plus here we know that this is the same as 2kq squared divided by a squared, or divided by a squared. Yeah, it's the same as that. Okay, so we can just take out common factor here. So our common factor is going to be k. If you can see, it's going to be kq squared over a squared, right? That's our common factor. And then on inside we're left with 4 divided by the square root of 2 plus 2, yeah, just plus 2. Okay, so now we already know how to arrive to the answer, because we got everything here. K, we have it, k is this one, and then a is that one. Then feel free to pause the video and substitute and tell me what's the answer. Okay, so we're back. So the answer of this is going to be, when you substitute k with the proper value, because k is equals to 9 times 10 to the power 9. If you substitute k by that and substitute a by this, you're going to get 6.6 times 10 to the power minus 8 Newton. That's going to be your vector sum. So we answered the question because they said we have to calculate the vector sum of forces that are exerted on the top iron. So we answered the question. Okay, thanks for watching. See you next time. Hey, don't forget to subscribe.